really serious that you need to know how long you travel, your pace length, and your feet to 66 steps. Yeah? Okay.
How do you figure out your pace length?
You mark out and then you count. We did that yesterday. Yeah. Yeah.
Do you walk normal?
Yeah.
Yeah.
Okay.
Yeah. Because if you're in the woods and you walk like this, then when you go to the really big hill and I'm going to say park, you're trying to walk like this up a hill. It's really hard. Yeah. So this is a tool called the Biltmore stick. You guys kind of wrote about it when that day that I was gone and I told you to write about like 6 tools. Yeah, remember that? Yeah. Okay. So on the Biltmore stick, there are 2 sides. One side says tree skill stick. One side says log skill stick. You're going to be measuring trees, not logs. So what side do you think you're always going to use? The tree scale. If you ever use the log scale, you are wrong, and that is not good, and don't do that, okay? We may have purposely wrote Cardington so that we can identify our Biltmore sticks at the contest, right? Across the side that you don't use. Okay, so don't use this side, use this side. Okay, so the log scale side would be if you go to like a sawmill and they're cut logs already and trying to measure them. That's what that is. So the Biltmore stick is a tool that is used to measure the diameter at breast height. Okay, so like literally, like everybody take your hands, put it out in front of you like this. All right, now go like this, like chop yourself. Okay, that is your breast height, right? For some of you, very obvious as to why it is called that. Okay, let's just be real. So diameter of breast height is basically your arm straight out from your shoulder. So that is a legitimate measurement in the Forest Service. Is what they call DBH, which is diameter at breast height. All right, so you're going to measure that using the Biltmore stick, and then you're also going to measure the height of the tree in 16-foot logs. So you're not, if you multiplied it out, you could figure it out, right? But you're not going to measure it by saying this tree is 50 feet tall. You're going to say this tree is 1 or 2.5 or whatever it is, 16-foot log tall. Okay, and the reason that they do that is because, again, the industry standard is that if you were to cut down a tree and you were to sell it to a sawmill, they would cut down that tree, they would cut them into 16-foot logs, and then they would take them and process them down into your 1x8s, your 1x6s, your 2x4s, whatever it is that you're getting in loads. Does that make sense? Okay. So a couple things to know is when you measure DBH and the height of the tree, is some of the times out in the woods, surprise, surprise, land is not perfectly flat, right? So if your tree is growing on a hill, it would look like that, right? Make sense? So when you do diameter at breast height, you always want to stand on the uphill side of the tree if it's on a tree, okay? Because otherwise, if you're down here, your diameter at breast height is going to come across the tree like this, and then you're actually just kind of measuring kind of the stump, and then if you were to cut it there, it would go like into the ground, right? So probably not that steep of a hill, but nonetheless, your diameter at breast height here, you would kind of go right across the tree like that. So you always want to be on the uphill side of the tree. When you measure, when you walk out your 66 feet, so this is this Biltmore stick is made using something called the Doyle scale. Okay, and the Doyle scale is a mathematical equation that figures out the diameter at breast height, but only by measuring it across with like a visual. And we'll talk about that maybe say if we have time, and definitely tomorrow, how you kind of visualize that. And so this scale measures the diameter of the tree with just being able to hold it up to the tree. Right? So it's like scaled back. This stick also is so that when you're 66 feet away and you hold this up and you just move your eyes, these little indications here on the side, this would be the height of 1 16-foot log, 2 16-foot logs, 3, 3.5, 4, 4.5, all the way up. So it's formulated again when you're that far away and you hold it up at that height, that then it would measure 16 feet. So it's very formulated. Somebody really, really smart went through and put this together. And now we just get to use this as the tool, right? So when you are using, when you step away to measure, when you walk your 66 feet away from the tree, in opposite, you do not want to walk uphill or downhill, okay? Because what I want for you guys to do is I want for you to take your thumb like this, put it so the top of your thumb is lined up with my head, all right? And now my head? What if I do this? Move it so it is. Okay, what if I do this? All right, so this is all visualized. When I went up and down, you went, right? So if you go uphill from a tree and you try to line up the height of it, and you're uphill from that tree, you're gonna be going like this to line it up, right? If you're downhill to get the tree, the ceiling's too short, but you're gonna have it. So you wanna be straight across the hill from the tree as much as you can. Does that make sense? So you do not wanna walk uphill or downhill. You wanna walk as straight across as you can to try and measure the height of that tree. Because this is all built on your perception, right? And the way that changes. So that's really important. When you go to measure the height of this, and again, we're gonna go out tomorrow and practice this. When you go to measure the tree, you're gonna line up the bottom of the Biltmore stick with where you would cut the stump. So you're not gonna line it up with the very where it meets the earth, right? Because on a tree like this, it might be, if you're standing downhill and you line it up with the earth right here, right? You're gaining some feet on that tree. So again, you're coming straight out from that hill, and then you want to line it up with where you would cut the stump. Because realistically, a man with a chainsaw is not going to go to that tree that's on a hill and go and like carve it out with the ground, right? They're going to take that chainsaw and about a foot off the ground, they're going to go, right? Tree falls in the woods, doesn't make sound, so is it? No. Okay. So, you want to cut it at what we call stump height, which would be like there-ish. Wherever when you look at it, you say, okay, this is probably where lumberjack back would go. And I'm off my game today. I'm not even all the way through my Mountain Dew. I'm mentally still figuring stuff out. Okay. Does that all those concepts make sense? Okay. So when you do this again, to do the height, you're going to hold it up straight out from you. Again, kind of your arm straight. And then you just, again, move your eyes upwards. Because now, put your thumb on me again. Okay, now just take your head and go like this. Don't move your thumb. What happened? Is the thumb still on top of my head? When you go like this, what happens to your thumb?
It stays in the same spot.
So you go, what?
No, your thumb stays there. You don't move your thumb.
But what happens in reaction to my head?
Be angled.
I removed your thumb on my head. All right, now keeping your thumb there, just pick your head up like this and keep looking at me. What's it doing? Down. It's going down, like right now I'm looking at Sarah's chin. Okay, now do the opposite. Put it on my head. Now put your head down and still look forward. It went up. It went up. Wow. So it's all about your perception. So when you go to measure the tree, all right, if I do this and then I look up at the tree, those numbers are moving, right? And so it's going to change what height I'm reading the tree at. So when you look, you want to keep your head straight and just move your eyes up to look at the height, all right? Now when you do that, you are going to measure the tree, not necessarily to the very tippy top of its leaves, right? But you're going to measure the tree until one of two things happens. Things number one is that a major branch comes out like that, and it starts to get kind of branchy, because at that point, when they cut that tree, they're actually going to have to kind of cut inward to get that branch out of there. So it's going to mess with the integrity of the log that they're trying to cut, right? That log's going to have a big divot in it, or they're going to have to cut it smaller. The other thing is if you cut this tree and it gets significantly narrower as you go up. Because what you're doing with this Doyle Steel Biltmore stick is you are basically taking the area of the tree. So you're using its diameter, or you guys know like box area is, what's the formula for that? What do you teach them in middle school math?
I didn't have any.
What's the, you guys know the formula for an area of a square or rectangle?
I don't remember that.
You're talking about the volume or the area?
Just the area.
The area is for two-dimensional shape.
Okay, length times width though, right? Is like your formula for that. So if I'm trying to figure out the area of this tree, this is formulated to the volume, whatever, right? But the concept is that you're taking the diameter, okay, and you're taking the height, and there's a nifty little chart on it is and however wide it is, this is how many board feet are in that tree. So by board feet, that's saying when you cut that to a 2x4, how many feet of 2x4 or 1x6 or whatever, how many square feet of board are you going to be able to get out of that tree? And again, somebody a lot smarter than any of us came up with this, right? Maybe not you guys, smarter than me, came up with this, and we trust Mr. Doyle, right? So your diameter, your height are what are factored into figuring out your board feet. So if you're judging that based off your diameter here and your height here, what happens up here? It gets a lot smaller, right? So since this tree is not consistently this wide, all the way up, if I measure all the way up where it gets skinnier, my calculations aren't going to be right? When it gets skinnier, I would need to remeasure that and then do the height. Does that make sense?
Yep.
Yes. All right, that was a very, very abbreviated version of how to use Biltmore stick. We'll go on a nature walk on Friday and practice it.